Today, I will introduce the working principle of an inverter to you. The function of an inverter is to convert DC power into AC power. Let's first look at how an AC square wave signal is generated. As shown in the video, the circuit includes 4 switches, a power supply, and an output load. This inverter is called a full bridge inverter. When Q1 and Q4 are closed, it outputs positive voltage to the load. When Q2 and Q3 are closed, it outputs negative voltage to the load. In actual control, the 4 switches use 4 transistors Q1 and Q4 to work simultaneously, Q2 and Q3. 2 groups work simultaneously and alternately. This inverter outputs an AC square wave signal. In practical applications, it cannot smoothly control the torque output of the motor. How is the sine wave controlled? The circuit used to realize the sine wave is called the pulse modulation circuit. We divide the sine wave type into multiple small segments. Each small segment is controlled by a different duty cycle, so that the average voltage of each segment is a different point. The higher the voltage, the greater the duty cycle. How is it implemented in the actual circuit? PWM modulation requires 2 comparators. The 2 input terminals of the comparator, one is a normal sine wave signal, and the other is a carrier signal. The carrier signal usually uses a triangle wave. One comparator uses a normal sine wave, and the other comparator uses an inverted sine wave. The first comparator controls Q1 and Q2. The Q1 and Q2 signals are reverse. Q1 is high potential and Q2 is low potential. This ensures that the 2 switching tubes work alternately. The second comparator controls Q3 and Q4. The control logic is the same. The working logic of the comparator is simple. When the sinusoidal signal is higher than the triangle wave, it outputs signal 1, otherwise it outputs signal 0. So we can see that the higher the voltage of the sinusoidal signal, the greater the duty cycle of the output. The 2 comparators use different signals as shown in the video. The voltage on both sides is the difference between the 2 signals, and the waveform shown is obtained. In this way, a smooth sine wave signal can be obtained. The higher the frequency of the triangular wave, the smoother the signal obtained. Hope you understand this. Like, comment, share, and subscribe.